Hello, we are Yangming and Dominic, and we are from Kaohsiung, Taiwan. Our topic is AI FML for Go win rate inference and robotic applications. This is our outline. And for introduction,
Machine learning is executed by means of regression, ensemble methods, and deep learning.
this is the process of our machine learning. Firstly, we have our original data, which we perform feature extraction and normalization. It forms training data, which by machine learning forms two models. One is the prediction model and one is the decision model, which we can perform testing by testing data. And for our Go project FUZZ-C variables, they're here. And for our role,
We lost the sound.
sorry, because the document is wrong, so we need to reopen another document. This is our knowledge-based criteria here, and this is our input and output. And for our Go project role base, there are 144 rule bases here. And this is our role base diagram. This is our black and this is the white one. And the question now is, why are there 144 role bases? 144 is calculated from the multiplying the parameters of the variables, which means 2 times 2 times 3 times 3 times 2 times 2, which equals 144. For our training data, our selection and normalization. Our selection, by separately running all 60 games through genetic learning. We then pick the 40 with the smallest MSE, and the rest will be our testing data. For normalization, the simulation number, SN, because it is relatively higher than other numbers and we want to control all our numbers between 0 and 1, we divide the whole column by the highest number in the column, and other kinds of data remains the same. Which you can see here, this is our training data. After, this is our original data, which you can see here. The simulation number, DBSN and DWSN is relatively higher. After dividing it, it becomes this. So all numbers are between 0 and 1. And it is better for we to perform the machine learning. For input and output.
And the goal, optimize the FML model by learning from the win rate predicted by ELF OpenGo. And this is our input, SN simulation number, like DBSN or DWSN, and WR, win rate, DBWR or DWWR by Dark Forest, and TMR, top move rate, DBTMR or DWTMR by Dark Forest.
And this is our knowledge base diagram. And this is our genetic learning results. And this is the visual FML after our machine learning. Then this is our testing, which we perform testing on game 20. And the lines of light blue and orange are the win rate predicted by Dark Forest. And the lines of gray and yellow are the ones predicted by ELF OpenGo. And with the lines with the darker blue and green is our results. And you can see that our results actually, it falls approximately between the two lines between the Dark Forest and OpenGo. So we can see that actually our model of machine learning is actually quite efficient. And for our inner testing and outer testing. Inner testing, we choose the testing data, and then we deleted our desired output, and then we perform inner testing. And it is meant to check the efficiency of our model. And you can see there's correlation between these two lines. And there are extreme numbers that are not represented by our model, and it is okay because numbers are too extreme. And the outer testing results remain the same. There are correlation between these two lines, which suggested that we have a good model. And our conclusions, by using genetic algorithm to optimize the knowledge base and rule base of the constructed fuzzy inference system. MSE has a decreasing tendency when the number of generations increases, and accuracy is not related to the alter of generation. And by performing testing, we have proven the efficiency of our machine learning mechanism, which means that our goal has finally been achieved. This is the end of our presentation. Thank you for listening. And if you have any questions, you can tell us right now, and we'll answer it for you.
Okay, thank you. Any question or comments? Yusuke, are you online?
I have a question. You mentioned at the end that there is a correlation between those plots. Why did you say that, and how can you quantify that?
Actually, we can see that the two lines have a similar, like, let me see. They look like they look similar in their linear one, and how do we? correlate？ The curvature of these two lines are similar.
So you're saying they have the same trend, right? They have they follow the same trend, right? That's how you good. Now, can you quantify that? Would you could you measure exactly how much they follow the same trend?
We could have. It needs to. I think it needs to run some kind of a program, but we don't have that, so we can only use. Yeah, we can't quantify it.
Okay. No, I'm just saying because, right, it's always good, right, in engineering to put numbers, right? So it's just not qualitative, but quantitatively, right, to make right, the measurement. So it would be nice to have at the bottom of this graphs some measurement of the actual correlation between the two curves, right?
You mean like the correlation and the shifting of the lines, such like this?
Yeah, you can do a correlation between the values, right? And figure out an index of correlation, right?
Yeah, thank you for a suggestion, and I think we may put this in our future research.
Perfect, thank you. Very good presentation, by the way. Good job.
Thank you.
Okay, thank you, Gui.